In this session, we are going to revise all what we have studied in calculus. And before we start, I want to show you the difference between a specified quantity and unspecified quantity. The specified quantity is the quantity we know its value exactly, like these values here. 3/5 is a specified quantity. 0.6, it's a decimal, is a specified quantity. And 1.3 is a specified quantity. And also the percentage is a specified quantity. And what is the meaning of an unspecified quantity? The unspecified quantity is the quantity we couldn't know the value exactly. Like, look at these values here. Infinity divided by infinity is an specified quantity. And 0 times infinity, infinity minus infinity, 0 divided by 0, and 0 raised to the power of 0, infinity raised to the power of 0, and 1 raised to the power of infinity. If we have a value like 3/5, you know this value is a specified quantity. We can say that this value is equal to 0/0. Why is that? If you do cross multiplying, you will get 5 times 0 equals 3 times 0. And that's right, 5 times 0 is 0 and 3 times 0 is 0. They are the same. So the quantity 0/0 is an unspecified quantity, okay? Undefined quantity. The undefined quantity is the value like 3/0. 3/0 is undefined quantity because there is no real number. If we multiply it by 0, the result will be 3. So 3/0 is undefined quantity. So we have till now a specified quantity, unspecified quantity, and undefined quantity. And the difference between unspecified quantity and undefined quantity, for example, 0/0 is unspecified quantity. This value exists, or we can say this value is hidden. We don't know what is the value of 0/0. 0/0 can be any value like 5/6, 8/9. And 3/0 is undefined quantity because we have 0 down here in the denominator. So this value is undefined quantity. What is the limit of this function at x equals 1? We are going to find the limit of a function at a point like this function here is x squared minus 1 over x minus 1 at x equals 1. When we substitute instead of x1, so it will be 1 squared minus 1 over 1 minus 1. And that leads to get 1 minus 1, it's 0/0. And 0/0 is an specified quantity. How can we evaluate the value of the function at x equals 1? At x equals 1 exactly, we couldn't find the value of this function. But we are going to find a value close to 1. Close to 1 like 0.9 or 0.99 or 0.999, okay? Or 1.1, 1.01, 1.001. So we are going to take values close to 1, not equal to 1, because putting 1 in this function, when we pass 1 instead of x in this function, you will get 0/0, and 0/0 is unspecified quantity. So let's evaluate the value of the function when x tends to 1. What is the meaning of x tends to 1? That means x approaches 1. It's not equal to 1 exactly, but we are going to take values close to 1, and we are going to find the value of the function when x equals some values like 0.9, 0.99, stuff like that. When we put instead of x a value close to 1. So here, look at this table. X equals 0.5. What is the value of the function? By using the calculator, it's 1.5. 0.6 is 1.6. 0.9 is 1.9. Okay. So what do you notice? As x approaches to 1 from the left, the value or the function approaches to 2. F of x approaches to 2 from the left also. When we take a value more than 1, just a little bit more than 1, like 1.1, 1.2, 1.3, 1.4, 1.5, stuff like that, we notice as we take values close to 1, closer to 1, we will get a value for the function close to 2. Okay, so as x approaches to 1 from the left, what the meaning of from the left? A value less than 1, like these values, they are the values from the left. As x approaches to 1 from the left, the value of the function approaches to 2 from the left. Okay, and when taking values more than 1, just a little bit more than 1, like these values here. So as you see here, x approaches to 1 from the right, because on the number line here we have 1, and from the right we have 1.1, 1.2, 1.3, 1.4. So this is the limit from the right, and here we have the limit from the left. X approaches to 1 from the right, and f of x approaches to 2 from the right, approaches to 2 from the right. So what is the limit of the function? As x tends to 1, it will be 2. And when graphing the function f of x, x squared minus 1 over x minus 1, as x approaches to 1 here, and trying to find the value of the function. When graphing this function, first of all, what is the domain of this function? The domain is r difference 1. Why is that? Because 1 makes the denominator 0. So that is the domain of the function. Okay. And when graphing this function, you will get a linear function, as you see here. And when trying to find the value of 1, the value of 1 here, we couldn't find the value of 1 exactly. Do you know why? Because the domain is r difference 1. And when taking a value close to 1 here from the right, here is from the right, and here's from the left. Okay. As x approaches to 1 from the right, you will find the value of the function approaches to 2. If we moved up here from this point, you will hit the line at 2. And when taking a value less than 1, just a little bit from 1, less than 1. So you will find, if you went up here, you will find any value less than 1. Okay, just a little bit less than 1. And draw a line up here, you will find that this line hits the function here, the linear function at 2. So the limit from the right, we call it f of 1 and positive up here. It's called the limit of the function from the right. It's 2 when x approaches 1. And the limit of the function from the left, as x approaches 1 from the left here, you will find the value of the function is 2. So here x approaches to 1 from the right, x approaches or tends to 1 from the right. It's not 1 positive, it's not positive 1, it's 1 from the right. And here x approaches to 1. This negative means x approaches 1 from the left. You will find the right limit, okay, is equal to the left limit. when x approaches 1 from the right is the same as x approaches 1 from the left. So because they are the same, so the limit of the function f of x when x approaches 1 equals 2. I want to study the opposite figure and find f of 1. So as you see here, f of 1, let's go to the graph. F of 1, here x is 1, f of 1 equals 1. When we get 1 here on x, go up, you will hit 1. So f of 1 equals 1. F of 1 from the left, what does it mean? Here is 1, so 1 from the left and 1 from the right. Here is 1 from the left here. 1 from the left is less than 1, a value less than 1, okay? So here a value less than 1, just go to the graph. When you get the graph, 1 from the left here is less than 1 by a little bit, and go up here. You will hit the curve at 2. So f of 1 from the left is 2, okay? And f of 1 from the right, what does it mean? F of 1 from the right, just go after 1, just a little bit after 1, more than 1 here from the right, okay? You will hit the curve at 1. So f of 1 from the right is 1. What is the limit of f of x when x approaches 1? Because the right limit is not the same like the left limit. F of 1 from the right is not the same like f of 1 from the left. They are different. So the limit of the function when x tends to 1 doesn't exist. There is no limit, okay? Doesn't exist. From the opposite figure, I want to find f of 0. So f of 0 here, when x equals 0, you will find f of 0 when going up here, you will hit the point at 1. So f of 0 is 1. The value of the function when x equals 0 is 1. F of 0 from the right. What's the meaning of 0 from the right? More than 0, just a little bit more than 0. So simply go to the graph, and after 0 here, go up, okay, after 0, and you will hit this line at 1 also. So f of 1 from the right here, f of 0 from the right is 1. F of 0 from the left, f of 0 from the left, it's less than 0, not equal to 0. So to do it simply, go to 0 and less than 0, just a little bit less than 0, and go up. You will hit the curve at 4. So f of 0 from the left is 2. Sorry for that, it's f of 0 from the left. Here, it's not 2. I wrote it as 2, but f of 0 from the left, when we go to 0 from the left, we will hit 4 here. So f of 0 from the left is 4, less than 0, just a little bit. What is the limit of f of x when x approaches 0? As you see here, the right limit is not the same like the left limit. So f of 0, f of limit of the function when x tends to 0 doesn't exist. Doesn't exist. Why is that? Because the right limit is not the same like the left limit. F of 2, go to 2 here. So f of 2, when going up here, you will hit this line at an open circle. So f of 2 is undefined. Undefined. And f of 2 from the right, the limit of the function when x approaches to 2 from the right, just more than 2, just a little bit more than 2. So here, more than 2, just a little bit, and go up here. You will hit the straight line at 3. So f of 2 from the right is 3. And f of 2 from the left, f of 2 from the left, just less than 2 by a little bit here, less than 2. You will hit the line at 3. So f of 2 from the left is 3. What is the limit of f of x when x approaches 2? Because the right limit is the same as the left limit, So the limit of f of x when x tends to 2 equals what? 3. How can we find the limit of a function algebraically? We can use factorizing, we can use the long division, and we can multiply by the conjugate. I want to find the limit of this function here. If we put instead of x -3 in this function, you will get 0 over 0, and 0 over 0 is unspecified quantity. This value exists, but it's hidden now. I want to get the value of this function when x tends to -3. So we can use factorizing here. X squared, we can write it as x times x, and two numbers, their product is 3 and their sum is 4. So we have here 3 and 1 divided by x squared minus 9. We will factorize it as x plus 3 and x minus 3. Then we are going to cancel x plus 3 and x plus 3. You know that x plus 3 is called 0 factor. This is the factor which makes the top 0, and this is the factor which makes the denominator 0. I have got rid of them. So you ended up with x plus 1 over x minus 3. X tends to -3. And in this case, you will put instead of x -3. So it will be -3 plus 1 over -3 minus 3. -3 plus 1, it's -2 over -6. It will be 1/3. Let's go to the next example. I want to find the limit of the function x cubed minus 8 over 3x squared minus 12. So if we substitute x equals 2 in this function, we'll get 0 over 0, and 0 over 0 is unspecified value. We can get the limit of the function if we factorize it, the top and the bottom here. So x cubed minus 8 is difference between two cubes. How can we factorize it? Open two pairs of arcs, a small arc and a large arc here. X cubed minus 8 is going to be x minus 2. I took the cubic root of the first and the cubic root of the second. Then I'm going to square the first here. The square of x is x squared, and the square of -2 here is 4. Okay, and multiply the first by the second, x and the -2, and change the sign. It will be plus here plus 2x. Okay, once again, what I did, I factorized it as x cubed minus 8, the cubic root of the first and the cubic root of the second, then square the first, which is x, squared the second, which is 4, and change the sign between them, make it positive because it's negative here, and multiply x times 2, all divided by 3x squared minus 12. 3x squared minus 12, but we can take 3 as a factor, so you are left with x squared minus 4. Then this can be factorizing. X squared minus 4 can be factorized as x plus 2 and x minus 2. So we're going to try to them again, 3 here and x plus 2 and x minus 2 here, and write the top as it. Okay. Then cancel the 0 factor. Cancel x minus 2 with x minus 2. You will end up with x squared plus 2x plus 4 over 3 multiplied by x plus 2. I have got of the 0 factor from the top and from the bottom. And then put instead of x, substitute x equals 2 in this function. You will end up with 1. You end up with 1. When we put x equals 2 in this function, it will be 2 squared plus 2 times 2 plus 4 over 3 multiplied by 2 plus 2. It will be 1 at the end. I want to get the limit of the function when x tends to -3. So here we are going to factorize it. How can we factorize it? x plus 2 to the power of 3 plus 1. So it's a sum of two cubes. Open two pairs of arcs here. One small and one large. And take the cubic root of the first, which is x plus 2 here. And the cubic root of 1 is 1. Then factorize the first, square the first. X plus 2 is going to be written as x plus 2 to the power of 2. Don't care about it. And then square the second, and right here at the end, it's 1. And then change the sign between them. It will be negative because it's a positive here. So write negative and multiply 1 by x plus 2. It will be negative here. And 1 times x plus 2, which is x plus 2. All divided by here, down. We can take 2x as a factor. So when taking 2x as a factor, you will end up with x here, 2x squared divided by 2x, it's x, and 6x divided by 2x, it's 3. And here we have at the top x plus 2 plus 1, so it's x plus 3. So we can cancel them out. One cancel another out, x plus 3 and x plus 3. Then I have canceled the zero factor from the top and from the bottom. Then you will put, instead of x in the function, you will put negative 3 here in the function. You will end up with its negative half. That's it. I want to get the limit of the function to x minus 2 over x minus 1 to the power of 5 plus 2x minus 2. So here we have a common factor at the top, which is 2. So we'll take 2 as a factor, then you will have x minus 1 at the top. And at the bottom here, we couldn't expand x minus 1 to the power of 5, so write it as x minus 1 to the power of 5. Then plus the two terms here, we are going to take 2 as a factor. So you'll end up with x minus 1. If we looked at the denominator, we have here down x minus 1 to the power of 5, and we have here x minus 1. So we can take x minus 1 as a factor, okay? And you are going to write the top as it to x minus 1 over. If we took x minus 1 as a factor here, okay? So you will get, because I have x minus 1 to the power of 5 is going to be divided by x minus 1. So it will be x minus 1 to the power of 4, okay? Plus 2 multiplied by 2x minus 1, and I took x minus 1 as a factor, so you have here 2, okay? Then you are going to cancel x minus 1 at the top and x minus 1 and at the bottom. When cancel another out, it's the zero factor at the top and the zero factor at the bottom. Then you will put, instead of x, 1 here. So it's a 2 over, you will get here 1 minus 1 to the power of 4 plus 2. So it's a 2 over 1 minus 1, it's a 0 to the power of 4, 0 plus 2, so it's a 2. 2 divided by 2 equals 1. Here, what is the type of factorizing? If we looked at the top, you will see 4 terms here. But we can factorize it by grouping. We can take x power 4 minus 2x cubed as a group, and right here plus, just to separate between them, you'll get here negative 6x plus 12. Because we have, at the first group, we have x power of 3 as a factor, and in the second group here, we have negative 6 as a factor. And down, if we went to the denominator, you will get x squared plus x minus 6, okay? So we are going to factorize it. We will get here x and here plus 3, okay? And x minus 2, that's it. So we are going to take the factor here, x power of 4 minus 2x power of 3. We are going to take x power of 3 as a factor. So you'll get here x power of 4 divided by x power of 3, it's x and minus 2 here. And in the second group, we are going to take negative 6 as a factor. What about this plus? This plus is put just to separate between them. So ignore it and write -6 here. And you will get, if we took -6 as a factor, you will get x minus 2. All divided by x plus 3 and x minus 2. What do you notice here? We have two terms at the top. They are the two terms. This is the first term and this is the second term. We observe that we have x minus 2. This factor is repeated. So we can take x minus 2 as a factor. When taking x minus 2 as a factor, you are left with what now? X cubed, okay, minus 6. All divided by x plus 3 and x minus 2. Then you will cancel x minus 2 with x minus 2. We ended up with x cubed minus 6 over x plus 3. Then we will put 2 in this function instead of x. So it's 2 to the power of 3 minus 6, all divided by 2 plus 3. So it's 8 minus 6, 2 over 5. That's it. In this example, we couldn't factorize x cubed minus 15x minus 4. And at the bottom, we have x minus 4. And if we put instead of x4 in this limit, you will get 0 over 0, and 0 over 0 is unspecified quantity. But in this case, we are going to use the long division. We are going to divide the top and the bottom by x minus 4. We are going to divide the top and the bottom by x minus 4, okay? So here you write x cubed minus 15x minus 4, all divided by x minus 4. Just to get rid of the 0 factor. And what are the steps of division? The first step to divide. Divide what? Divide the first by the first. So you are going to divide x cubed divided by x is going to be x squared here. And then the second step to multiply by all. Multiply x squared here by x. So once again, what I said, I divided the first by the first. I've got x squared. Okay, then multiply what you have got here, which is x squared, multiply by all here. So x squared times x is going to be x to the power of 3. And x squared times -4 is -4x squared. And then subtract the change sign. Subtract the change sign. So this one here is negative, and this one is going to be positive here. Okay. Cancel x cubed and negative x cubed. We are going to cancel them. X cubed and negative x cubed. And now you are left with 4x squared here minus 15x minus 4. And do the same steps. Divide the first by the first. Here is the first, divided by the first. So 4x squared divided by x is going to be what? Is going to be 4x plus 4x. Then multiply what you have got here, multiply by all terms of the divisor. So 4x multiplied by x, 4x multiplied by x is going to be 4x squared. And 4x multiplied by -4, it's negative 16x. Then subtract the change signs. So this one is going to be negative here, and this one is going to be positive. Cancel them out. And negative 15x plus 16x, so it's x here. And drop -4. Then divide the first by the first again. Do the same steps. X divided by x is going to be 1. X divided by x is going to be 1. Then multiply this 1 by all terms here. So 1 multiplied by x is x, and 1 times -4, so it's -4. I've finished because I'm going to change the sign here, negative, and here it's positive. Positive, cancel them out, so it's 0. So when dividing x cubed minus 15x minus 4 divided by x minus 4, this is the quotient x squared plus 4x plus 1. So we can write this expression here as, x minus 4 multiplied by x squared plus 4x plus 1, all divided by x minus 4, all divided by x minus 4, okay? Then you are going to cancel x minus 4 and x minus 4. So you ended up with x squared plus 4x plus 1. Put instead of x, x tends to 4. So 4 squared plus 4 times 4 plus 1 equals 33. As you see here, it seems to be complicated. But if we use the long division, we will make it easy. But how can we use the long division here? What is the zero factor? The zero factor, look at x tends to 1. So the zero factor is x minus 1. This is the zero factor. Okay. So we can just take x down here as a factor at the denominator here. So if we take x as a factor, you will end up with x squared, okay, minus 2x plus 1. And this expression can be factorized down here. This expression can be factorized. So leave the numerator as it and just focus on the denominator now. So x squared minus 2x plus 1 can be factorized as x minus 1 multiplied by x minus 1. The zero factor appears here. So we are going to divide all these terms here. We are going to divide it by x minus 1. We are going to divide it by x minus 1 here. So you are going to write x cubed minus 5x squared plus 7x minus 3 and divided by x minus 1. What are the steps of division? Like the previous one, divide the first by the first. This is the first divided by the first. So x cubed divided by x is going to be what? X squared. Then multiply by all. X squared multiplied by x is going to be x power of 3. And x squared multiplied by x is going to be what? Multiplied by negative 1 is going to be negative x squared. And then subtract the change signs. This one is going to be negative and this one is positive. Cancel x cubed and negative x cubed. Then you will get negative 5x squared and x squared. So it will be negative 4x squared and then drop 7x down and drop negative 3 down. Then follow the same steps. Divide the first by the first. This is the first divided by the first. So negative 4x squared divided by x, negative divided by positive, it's negative, and 4 divided by 1, so it's 4. X squared divided by x, so it's x. Then multiply by all. Multiply negative 4x by x, so it's negative 4x squared here. And negative 4x multiplied by negative 1 is going to be 4x. Then subtract, change signs. So this one is going to be positive and this one is going to be negative. 4x squared and negative 4x squared, cancel them out. 7x minus 4x is 3x, then drop negative 3. Divide the first by the first. So 3x divided by x is going to be what? Is going to be 3. Then multiply by all here. 3 times x, it's 3x. And 3 times negative 1, it's negative 3. Negative and positive here. I have finished. So we can write this expression as x minus 1 multiplied by x squared minus 4x plus 3. And this can be factorized. So you are going to write x minus 1 here. Two numbers, their product 3 and their sum negative 4. They are negative 3, x negative 3, and x negative 1. Then simplify. cancel x minus 1 and x minus 1, and cancel x minus 1 and x minus 1. Then you ended up with x minus 3 up at the top and x at the bottom. X approaches 1, so it's going to be 1 minus 3 over 1. 1 minus 3 is negative 2 over 1, which is negative 2. Let's go to the next. How can we find the limit here? We can find the limit by multiplying by the conjugate. What is the conjugate? What is the meaning of the conjugate? If we put 5 in the limit here, you will get 0 over 0, and 0 over 0 is unspecified value. So we are going to change it by multiplying by the conjugate. What is the conjugate? Just to change the sign between here, between them, it's negative, so make it positive. So multiply by square root of x minus 1 plus 2 at the top and at the bottom. X minus 1 plus 2. Just to get rid of the zero factor. Okay? So multiplying them here, deal with them as two terms, the sum of two terms, multiplying by the difference between them. When multiplying the square root by itself, so square root of x minus 1 multiplied by square root of x minus 1 is going to be what? X minus 1. And multiply the second by the second, it's negative 2 multiplied by 2, it's negative 4. Down here. You are going to write it as x minus 5 multiplied by the square root of x minus 1, then plus 2. If we look at the top here, you will get x minus 5 at the top because we have negative 1 and negative 4. So it's x minus 5. All divided by x minus 5 multiplied by the square root of x minus 1 plus 2. Then cancel x minus 5 and x minus 5. You ended up with 1 over square root of x minus 1 plus 2. X tends to 5. Okay? So when x tends to 5, so 1 over, and instead of x here, write 5 minus 1, then plus 2. And the square root of 5 minus 1, it's 4. The square root of 4 is 2. So it's going to be what? 1 over square root of 4, it's 2 plus 2. So it's 1 over 4. That's it. The next one, we are going to find the limit by multiplying by the conjugate. So here we have x squared minus x minus 6. We can factorize it. It's x minus 3 and x plus 2. All divided by the cubic root of 5x minus 6, then minus 3. What is the conjugate? The conjugate is the same here, but just change the sign between them. So you are going to multiply it by square root of 5x minus 6, then plus 3 up here, and the square root of 5x minus 6 and plus 3 down. So it's x minus 3 at the top, multiplied by x plus 2, and all of them multiplied by square root of 5x minus 6, then plus 3. All over divided by the square root multiplied by itself. So we are going to write the expression without the square root. So it's going to be 5x minus 6 here. And negative 3 multiplied by 3, it's negative 9. Okay. What is the next? So write the top as it, and we will get down here. I'm going to complete in this area. So it's x minus 3 multiplied by x plus 2 multiplied by the square root of 5x minus 6 plus 3 all over divided by 5x minus 15. Okay, then we can take 5 as a factor down here. So it's x minus 3 right to the top as it, multiplied by x plus 2 multiplied by we can complete it by take 5 as a factor here. Write it as it. Take 5 as a factor. So it will be x minus 3. Then you are going to cancel x minus 3 and x minus 3. So we ended up with, pay attention, it's x plus 2 at the top, multiplied by the square root of 5x minus 6 plus 3, all over divided by 5. And x approaches 3, so I'm going to put 3 in this limit here. So it will be 3 plus 2, 5. Okay, square root of 5 times 3, 15 minus 6. 15 minus 6, 9. Square root of 9 is 3, and 3 plus 3 is 6. Okay, so it's 30 divided by 5, it's 6. So the limit equals 6. We can use the calculator to find it quickly. Here in this example, we have two conjugates. The two conjugates, we have the conjugate for the numerator and the conjugate for the denominator. So we are going to multiply the top and the bottom by the two conjugates. How can we do it? Look, it's the square root of x plus 1, okay, minus 2 at the top, and down it's the square root of x minus 2 minus 1. So what is the conjugate of the denominator? The conjugate of the denominator, just change the sign. So we are going to multiply the top and the bottom by the conjugate of the denominator. And we are going to multiply this fraction here by the conjugate of the numerator. So we will multiply it by the square root of x plus 1 here, then plus 2 at the top and at the bottom. But write it far away in the second fraction. I multiplied by the conjugate of the numerator, the top and the bottom. Then multiply by the conjugate of the denominator, which is the square root of x minus 2, then plus 1, down, and up, just to make balance between them, x minus 2, then plus 1. So multiply them. It's square root of x plus 1 minus 2 multiplied by this 1 here, the conjugate. So it's going to be x plus 1, then minus 4 at the top. Then write the second as it's the square root of x minus 2, then plus 1, divided by x square root of x minus 2 multiplied by the square root of x minus 2. So it's x minus 2, and negative 1 multiplied by 1. So it's negative 1. And write the second, x plus 1, then plus 2 equals x plus 1 minus 4. It will be x minus 3 at the top, all divided by x minus 2 minus 1. It's x minus 3 at the bottom, multiplied by the square root of x minus 2 plus 1 at the top, x plus 1 plus 2 at the bottom. Cancel them out. We ended up with the square root of x minus 2 plus 1 over a square root of x plus 1 plus 2 when x approaches 3. So put 3 instead of x, it will be 2 at the top, and at the bottom it will be 3 plus 1, 4, 2 plus 2, 4. So it will be 2 over 4, which is half.